Hi, I'm Mike Walker. Thank you for joining this presentation. And today I'm going to be talking about the benefits of using time-based data with Informix time series. So I'm going to talk about what is time series and how it can be used. So first of all, starting with time-based data. So time series is best used when we're trying to capture data that has a time component. So think of anything where we might want to plot a value over time, then that might be a good candidate for using time series. So where does time-based data come from? A variety of sources. You can imagine doing a scientific experiment where you're measuring changes in something over time, or stock changes with ticker symbols and plotting the price of a stock over time. And a lot of data comes from sensors and especially the Internet of Things. So let's talk about the Internet of Things briefly. So the Internet of Things, where there's literally billions of devices all around the world, each one generating a ton of data over time. Now, it's important we store that data as efficiently as possible. We're talking very high volumes of data coming in very quickly. And so we need to be able to save it off very quickly, but also be able to retrieve it fast so we can run analytics against it. And because of the volumes of data that we're talking about, we need to be very careful how we store that data so we can store it compactly. Now, we really are talking about a lot of data here. One example is smart meters. So the US has a lot of smart meters now. And as an example, an electric company has about 6 million meters that it monitors, and it reads those meters every 15 minutes. Now, that alone, just for this one utility company, is going to generate over 210 billion electricity readings e- each year. Billions of records, we've probably all dealt with that. It's not that big a number, but when you start thinking about this over time, in just 5 years, that electricity company is going to have to store over 1 trillion meter readings. So you might be thinking the best place to store this is in a relational data model. This is the traditional way. So this would have a parent-child type uh, model where the parent record might be your meter, or in this case, sensor. And it stores data on that sensor, where it is, some other information about it. Now in comes a reading. In this case, it's a temperature reading. It comes in with a timestamp, and it is for this particular sensor. So it has to have a key, has to have a link back to the parent record. So this is a record in our child table. A minute later, in comes another temperature reading. And again, it links back to that parent record. And lastly, we've got a third record another minute later. Now, in this type of model, each of the child records needs a key value to point back to the parent record. So all these temperature measurements can be tied to a particular sensor. Now, they've each got a timestamp in there, but considering these are coming in regular intervals, do we really need that? It means we've got to store it for every child record. And each record we have, there's a little bit of overhead. Now, really all we're interested in for this particular sensor is that temperature reading. So we've got a lot of other stuff just to maintain this model when all we need is that simple temperature. Now, a time series model is a bit different. So this is a really fast way to store that data that has that time component. And it's best used when we're talking about simple data like temperature readings, that kind of thing, electricity readings. Um, it's not the sort of thing you'd use for like a customer record. Let's say a customer record may change over time, but it's not the sort of thing that you would normally be plotting as to when those customer records changed. Now, as opposed to the relational model, time series stores the data elements in a column form. So instead of those child records, all the values get stored in a single column, which just gets appended to. Now, time series is not an add-on or anything for Informix. It's included in just in the base product. So looking a bit more at how we're storing the data. So we instead of having that parent-child record, we just have our well, this is our parent record here, and stores the same information about our sensor. However, we've just got this new column in here that is storing our measurements, and that's our time series column. Now, you'll notice there's no timestamp associated with these. We don't need that when the data comes in at regular intervals. We know, as long as we know what the starting point is of that time series, we know the timestamp of any of the readings based on an offset from that origin. So this is what the data looks like. So we've got our sensor information, and the information in red are our data readings. So we can see there's some metadata at the beginning, which tells us when our time series started, how frequently it comes in, and where it's being saved. Now, back to our electric company that's got 6 million meters. Even though it may have billions or even trillions of data points, we still only have 6 million base records because we'd have one for each of those meters. Now, I mentioned about regular uh, data coming in. So with time series, we can have regular or irregular. So regular is where data comes in at particular points in time where we can expect them. That might be like a temperature reading where you might be sampling every minute, every hour, whatever, but you know when that next reading is expected. For that, for regular data, we don't need to store that timestamp. So that means our data will be stored more efficiently. Now, in order to maintain that offset, if no data is received or saved for a particular slot, then we'll put in a null in the time series. That will happen automatically. Now, what's different is a regular time series. So this is when the data does not come in expected intervals, but maybe only when a certain condition happens. An example would be when there's an error conditioning from a sensor that's out in the field. Um, it only needs to send information back when something's out of range, and it'll come back with a timestamp. Or when a door is open, you don't need to save information each time the door is closed or even open, but when there's a change of state. And that's when you want to send some information back with a timestamp and what the new state is. For a regular time series, we do need to store that timestamp. Now, I did some testing the other day as to how much storage we can actually save by switching from a relational data model to a time series model. So I just threw together a few sensor readings and for different intervals and so on. And I calculated that we could save up to 70% of our storage requirements by using time series over relational. Now, I've got two sets of numbers here, a set that includes an index and a set that excludes the index. So my thinking here was that with the parent-child relational model, you'd have overhead of an index that you'd need on those child records so that you could pick data for a certain time range. With time series, all the indexing is internal, so we can save space by not having that index that we'd have in the relational model. But I looked at it both ways. How much space would we save if we have that index or compared to a relational table with that index and without? Now we see that the regular um, time series is stored more efficiently than irregular, but this was really not a good use case for irregular um, time series because the data was coming in regular intervals. So we was incurring overhead by storing a timestamp when really it was not necessary. So with time series, you can really reduce the amount of storage that you need. Um, Now, we hear that storage is cheap and everything, but when we're talking about the kind of volumes here that we are with Internet of Things and with millions of meters, that really becomes significant. You might be talking going from terabytes of data to petabytes of data. And in fact, I'm working with some folks right now who are trying to mirror some of the time series data that we're storing in Oracle Exadata. And it's actually become prohibitive just because of the additional storage that they need. So that they're having to reduce the amount of data that they can actually mirror. Now, as well as the savings with storage, uh, we're also going to get improved performance from time series. And that's because now our data is so much more compact. So every time we do a read from disk, uh, with each of those reads, we're gathering a lot more data. All of those um, meter readings or sensor readings that we get back in one read. And of course, that goes along with savings in our cache. We can store much more data now in our cache than we could with a relational model. All of that leads to increased performance. So, how do we create a time series? There's a few simple steps. An optional step is creating a calendar, which is essentially saying when the time series started and what is considered a valid reading and an invalid reading. Uh, but Informix has some built-in calendars already that we'll use in our next example. So we create a row type, which defines the type of data that we'll be storing in the time series. A container, one or more containers, which specifies where we're going to store that data. And finally, we create a table now with one of these new time series columns uh, um, that will reference that row type. So let's look at an example. So I'm going to start with creating the row type. So here, this is equivalent to our child table, like the schema of that child table, if you like, in a relational model. So we need to have the timestamp in there, and that's regardless of uh, regular or irregular time series. We need that timestamp, and then we follow that with uh, the readings that we want to take. In this example, we're storing a temperature, humidity, and a light level. So this is a row type, and we will use this in a little bit when we create the table. But as you can see, it's got similar information that we'd have in that child table in a relational model. Secondly, the container. This specifies where we want to save off that time series data. So we give it a container name, a DB space, and we need to give it the row type here too. So Informix knows how to assign the data inside that container. And lastly, we're going to create our table. So here, this is just a simple table where we've got our information on our sensor. That's our kind of static information, and now we've got our time series column. And the data type here is a special value. It's time series, but then we specify the row type that we created earlier. And that will indicate how the data should be stored. So now we've got our infrastructure set up with our table and our row type and everything and our container. We're now going to create our first record. So we insert into that table we just created, we give it our static value for our sensor, but then we kind of initialize, if you like, the time series column. This is our metadata. So here we're using a special function, ts create, and we give it the calendar we're going to use. And here I'm using one of the built-in calendars that says I'm expecting data every minute. and I give it the origin of when the data starts from. So that's our starting point from which the other values will be calculated. And I tell it where that data is going to be stored in that sensor container. Now, each of these functions that I'm going to mention for time series, they've got a bunch of other options. I'm not going to go into all of them. They are well documented. So now we've got our base record in there, but we don't have any time series data. Now, with time series, you think of it not really inserting new data, but instead you just update the base record with the new time series reading that you've got. So here we've got an update statement, and we're using another time series function, put elem. So essentially save off this data element. And we tell it the time series column, because a table may have multiple time series columns, so we can specify which one we're updating. And then we give it the data. So there's our timestamp, followed by the three readings. I think it was temperature, humidity, and light level, and we specify the row type. So Informix knows that this how this row is formatted. So let's see what that data looks like. So we're querying the table, just regular SQL here, select star from sensor, and we see that base record followed by our time series, and we see our origin, as that's our starting point, if you like, of the time series in that column, our calendar and everything. So that's all stored as metadata at the start of every time series. And then our three values are saved, um, and you can see they're represented, the three values surrounded by parentheses, and each new value is separated by a comma. And some nulls there at the beginning because that serves as like placeholders, if you like, to offset the first reading. So even though our origin here was at 6:30 p.m., the data didn't start coming in and for a few minutes, and so that's why we have those nulls in there. Now, the time series data does look a little different, and you may have reporting tools, for example, uh, that can't work or are not designed to work with that kind of time series data looking the way it does. So there's a, a virtual table interface similar to a view, if you like, but it can be built on a time series and it will display the data in a more common relational format. The data underneath is no different. This is just a way to access that time series data in where we see one record per time series entry. So that's a very easy thing to do. We call a procedure TS create virtual tab, and we give it just two things. We give it the name of the virtual table we want to create and the table which we're creating the virtual table on. And that's our table that has our time series. So how does this look? If we query the VTI, the virtual table, instead of um, the underlying time series table, we'll see the data, um, and it's like if you join that parent and child table. Um, so you have one entry here, one record returned for every time series reading, and the timestamp is included, even though this is a regular time series in this example. So we have our base table information repeated, and then our timestamp, temperature, humidity, and light level. Now we can query that sensor data. Here I'm using a get last elem function. Again, another time series function. And here we query, we just want the latest value in that time series. And this function will return it for us. And here's an example of the output. So we see our base information followed by the latest value for each of the sensor records that we have saved in that table. Now, I'll go back to this slide. You see that some of the values are empty, like the humidity and light. That's because we have, in my example, which is set up around the house, uh, well, I've got different types of sensors. Some are returning temperature, humidity, and light level, but I've got other simpler sensors that are just returning the temperature. Now, in our time series, we defined our row type to store those three values. Um, but because we got some sensors that just send temperature, when we look at the time series for those sensors, we see these nulls in there, indicating that no value is received for that data element. And it's a bit wasteful. Now, this is a good case for using NoSQL. Now, Informix supports NoSQL. In fact, has a native JSON data type, and we can use that with time series. So NoSQL uses key value pairs where there's like a key value. In this case, we've got our temperature or our humidity, and then our value that goes with that key. So the nice thing about this is that for sensors that only return temperature, for example, we're only saving the temperature. For those sensors that are returning more things, we can save it all. Just it will just specify different keys. So this addresses a problem of like, what if you add a new sensor? This one returns something different. In my example here, we got volume, whatever, like a noise level. We don't need to make any changes to the schema. We don't need to change any of the existing data, but instead we just now have data coming in that's got a new key. So this is pretty easy to set up in time series. We follow the same process with a container and everything. What's different is our row type. Instead of having to specify all of the values that we want to save off, we just specify, in this case, a BSON data type. So if we look at the data here, it looks a little complicated, but that's partly because in this example, we're using an irregular time series. And remember, with the irregular, we save off the timestamp of when that data was received. So we've got our metadata here, and we see it's irregular, but then we've got our NoSQL documents, our key value pairs here with our temperature, humidity, and so on, followed by a timestamp. Now, Informix does provide a Mongo interface. It's got a Mongo listener that you can set up, and then you can use any Mongo application and plug it directly into Informix. So here's an example where I used a Mongo application that just allows me to query data, uh, presumably from a Mongo database, but I just pointed it to Informix using the listener, and I can retrieve that time series data um, using the Mongo syntax. Now, time series adds a whole lot of functions just so you can work with the time series data. I've given a few examples here. So you've got clip, which allows you to pull data between any two particular timestamps, um, and just show that so you don't have to read all of your data. We can do counts if a certain condition is met. We can count the number of elements in a time series, which is useful. And another handy function is the transpose. This works similar to the VTI and allows us to take some data, time series data, and present it in a more relational format. And I find using the transpose can be faster in some cases than using the virtual table. Now, all of these functions and many, many more are documented on the website, on the IBM website. Now, containers are where we're storing the time series data. We can use rolling windows, which now allows us to set up time series with specified retention intervals. So we can break data up maybe into like month periods, so month windows, and we can define rules to say after 12 months, uh, take the latest set of data, like month 13, and make it dormant. And then when we start a new month and we start saving off data, that dormant month will drop. So that data will be removed. So that makes administration of time series a lot easier by using these rolling windows. And we can change our containers. There's a TS container manage function, which allows us to modify some of the parameters that are associated with a container. And we can delete the container with the destroy function, container destroy. And a TS container usage is one of several functions that allows you to see how much space we're using inside a container, the number of elements, and how much room it's taking up. So time series does present an interesting problem when you're trying to manipulate that data, like trying to unload it or load it. Um, as you saw, uh, now our sensor table has this enormous column. It's just going to get bigger and bigger. It does create issues when you try and unload that data because you're just dealing with this massive column. I've had problems using external tables. I like using external tables, but for time series, they don't seem to be a good match, especially when you've just got long columns. You can use just regular SQL as an unload to unload that data in ASCII format. And using parallel processes really helps that, helps the performance there. And you can load that data again with SQL. There's also a bulk load function, but the time series loader is a set of functions that is extremely fast. We've had great results using that to load data very quickly. A few notes before we wrap up about time series. If you are using it, use the later versions, especially in 12. A lot of changes were made, bug fixes, and especially performance problems were addressed. So early versions of 12, you may have some issues with, and you'd see an advantage by upgrading. Some of those early versions did allow you to use time series in a no logging database. That was a bad idea. Um, so time series, it's interesting that there's some supporting tables within the same database, kind of like catalog tables that keeps track of where the time series are being used and how many you've got and other things. If you're not using logging and you run into some issues, then those tables can get out of sync and can lead to some corruption. Uh, and for the same reason where you've got these supporting tables, time series deletes are very slow. And it's not just deleting the time series itself. If you try and drop a table with time series in it, it spends a long time trying to adjust those catalog tables um, to reflect that the data is being removed, the time series data is going away. If you are using rolling windows, be careful of how big you make those windows or how small you make those windows. For example, uh, if your rolling window is set up with a day calendar and you're storing data maybe every 15 minutes, that's only 96 data points per 24-hour period. The rolling window or the window can only be a minimum of one page. So if you've got a 4K page and it's set up as to use daily windows or a window of one day, then you're storing maybe only 96 values and maybe they're simple integers or small ints or decimals. You're going to have a lot of wasted space inside that window. Wherever you can, spread those containers over multiple DB spaces. If you just keep adding everything in one DB space, when you try and do an archive using OnBar and doing parallel backups, you may find that the overall length of time for your archive is based on one DB space that just has all your time series in it. If you want to play with time series, the run DB access demo to create the stores demo database, as long as you don't use the dash no TS option, it will create a few simple uh, time series tables. So where does Informix fit in here with its time series? Well, it can run on the sensors where you're actually collecting the data. It can run on a hub that may be which connects to multiple sensors. Um, but the same time series can run on your enterprise. And of course, Informix also runs in the cloud. So it can run everywhere. But why Informix versus other things? Informix has a small footprint, and so it can run on ARM chips. So it can run on Raspberry Pis all the way up to your massive enterprise servers. Um, so Informix has relational data capabilities, of course, always has. And then we can now add in time series functionality. That sits alongside NoSQL functionality, can handle spatial data and other um, other things. Now, all of that is in one product. You don't, if you've got a Informix database handling your relational data, you don't need to go out and get another product just to store time series or spatial data. MQTT is now built in, so you can very easily set up sensors that automatically save off time series data to your database. Formix runs with Node-RED. There are nodes to save and read time series data, and using that, especially on some of your edge applications, is a really great way to set up monitoring sensors very easily. And we've spoken about the uh, the space savings for time series. Um, and that it only gets better with compression. Time series can be compressed, and in Formix 14, that is available with your current license. So we can make that data even smaller. Just before we wrap up, a few words about our company. Um, we specialize in Informix consulting, and we do remote DBA support. So we've been doing a lot of upgrades and migrations recently. So let us know if there's anything we can help you with. So thank you very much for attending this presentation on time series. And my email's here. Reach out if you have any questions. Thank you.